So in this video, we're going to graph the cubic function and its inverse. We'll see if we need to do any kind of domain restrictions to make sure that the cubic function can be inverted. So we've got the x cubed function here, and we've got a set of ordered pairs that for every ordered pair for x, we cubed that value to create the y value. So negative 2 to the third power is a negative 8. Same thing with all the rest of them. So let's go ahead and graph those. So negative 2, negative 8, negative 1, 0, 0, positive 1, and then positive 2, positive 8. Now, I tend to draw the cubic function in two parts, or else I just don't seem to be able to draw it very well. So that's the basic cubic function. Is it a function? Yes. Is the function invertible? Yes. So this is not going to require us to do any kind of domain restriction to find the inverse of the function. Domain is all your possible x values and everything is possible. There are no restrictions. Range is all your possible y values. No restrictions or issues there. X-intercept, 0, 0. Y-intercept, 0, 0. All right, so that's the cubic function. Let's take a look at finding the inverse of the cubic function. So step one is going to be to switch x and y. So actually I'll change color here. Let's see, x is equal to y to the third. And now step two is going to be to solve for y. So if I get kind of zoom in on that function, we've got y to the third. So I want to think about what will undo a third power. And what will undo a third power is a cube root or a third root. So the third root and the third power cancel. So you're left with y is equal to the cube root of x. Now, because this is a cube root, there is no plus or minus here. The plus or minus will only exist when you deal with even roots. So cube root is not even. So that is the inverse of the cubic function. So y is equal to the cube root of x. And basic idea here is the same thing. We're going to switch these x and y values from this table for the inverted function. I know I'm going to say that word right eventually. All right, so negative 8, negative 2, negative 1, 0, 0, 1, 1, and then 8, 2. So using this table of values, I'm going to go ahead and graph this. So let's see, negative 8, negative 2, negative 1, 0, 0, positive 1, and then positive 8, positive 2. So same basic curve, but it's been rotated. That's actually what an inverted function does. It rotates it because we've switched the x's and the y's. So with this new graph that we've just drawn, this is the cube root graph, cube root function. I said it's a function, so yes. The domain here are all your possible x values. That's going to be negative infinity to infinity. Range are all your possible y values. Again, negative infinity to infinity. X-intercept, 0, 0, and y-intercept is also 0, 0. All right, so that's the cube root function. So let's talk about the inverses of power functions. So given each power function, write the inverse function for each and include any restriction so the inverse is a function. Now I'm going to kind of do these weirdly out of order. I'm going to deal with all of the even root functions first because those are going to be the ones that I have to do domain restrictions. So f of x is equal to x to the fourth. So the inverse of x to the fourth would be the fourth root of x. So y equals the fourth root of x. And in this case, y has to be greater than or equal to 0. Okay, so that would give us the restrictions for our inverse function. Yes, okay. So that's one of the even roots. Let me slide over here. We've got the sixth power. So that is going to be y equals the sixth root of x. And again, y has to be greater than or equal to 0. All right. And the last even root one, yeah, you can have a power of 314. That's an even number. And that power has a 314th root of x, and y is greater than or equal to 0. It's okay. It happens. So those are the ones that need domain restrictions or a restriction. The other values, so all of the other three are odd roots. So this is going to be y equals the fifth root of x, no restrictions whatsoever. Let's go f of, nope, I lied. Y is equal to x to the 57th. So that 57th power, there is a corresponding 57th root. Let me fit the 7 in there. There you go, 57th root. And the 7th power would have a corresponding 7th root. Now, one thing I do want to comment on for these inverses. Every one of them I wrote as y is equal to. You actually, if you know, in this case, I'm purposely creating things that are inverses. So what you can actually write is f inverse of x is equal to the fourth root of x, or f inverse of x is equal to the seventh root of x. So this notation is the inverse of f of x. All right, so just be aware of that when you see that notation. The one thing you want to be careful about is that this f of x function had to be invertible in order for you to use this function notation as the inverse function. So remember, to be invertible means that this function has an inverse that is also a function. So be just a little bit careful with that notation. All right, so I'm going to go ahead and close the video here. If you've got any questions or concerns,